So what is ion selective electrode? ISE. ISE is a chemical sensor designed to measure the concentration of a specific ion in a solution. For sodium measurement, the electrode tip contains a sodium-sensitive glass membrane. When placed in the sample, the membrane exchanges ion with the solution, creating a voltage that correlates with the ion activity. This voltage is converted into a concentration value. So, what are the purposes of ion selective electrode? ISEs are widely used to determine sodium in foods such as cheese, butter, and salted products. They provide rapid analysis, good accuracy, and strong correlation with reference methods like atomic absorption spectrometry correlation 0.99. For example, in cheese analysis, result by SA result by ISE differed from atomic absorption by only plus minus 0.06% sodium.
So, for the working principle, how did it work? So, the measured potential is proportional to the ion's activity, which is effective concentration, and interpreted via the Nernst equation. Based on selective ion exchange through a special membrane, for example, sodium sensitive glass. When the electrode is dipped in a solution, the membrane interacts with the target ion, creating a potential difference, which is a voltage.
So next is the application of the ion selectively electrode. First, it's widely used for sodium determination in foods like cheese, butter, processed meats, soup, and salty snacks. Second, it's helpful for nutritional labeling and quality control. Third is provide fast result for routine monitoring in food industry. And lastly is the best for medium to high sodium samples, less reliable for very low sodium or fat rich food. So next, we're going to go to the procedure of ISE. Firstly, we need to calibrate. Electrode calibrated with standard sodium solution of no concentration. Secondly, the sample preparation. Food samples are homogenized and dissolved or extracted into the solution. Third, the measurement. The electrode is immersed into the prepared sample and the voltage is recorded. Fourth, calculation. The instrument software or calibration curve convert the potential reading into sodium concentration. And lastly, cleaning and condition. Electrode is rinsed and stored properly to maintain efficiency. That's all. So we're gonna go to the next part.
Here we have strength and limitation. For strength, which is quick, it is around 7 to 8 minutes per sample, including calibration. Then, simple, it is simple, is inexpensive, and highly accurate for many foods. And it is also good agreement with reference method like atomic absorption spectrometry, also known as AAS. Correlation, which is 0.99. Then, for its limitation, it is lower precision for low sodium foods, which is lower than 140 milligram per serving. Then it is also fat rich food cause interference like cookies, peanut, and almond butter. And it is not reliable at very low sodium level, like below than 100 micrograms. Lastly, it is require careful calibration and electrode maintenance. Lastly, we have two example of ISE devices, which is automated, which is frequently used in industry or labs, and then we have a standard, which is commonly used in the labs.